Hello, hi. Okay, in our previous session, I already show you how to form your complex number in a polar form. Okay, for this question, it is quite tricky because this question is basically we want to express the complex conjugate of 1 plus 2i in the form of polar form, which is r cos theta plus I sin theta. So therefore, from this complex number, we need to find what is complex conjugate for this complex number. Okay, this is the division of complex number. So we need to change this division of complex number into a general form of complex number. So what is general form of complex number? Okay, so the general form of complex number is a plus bi. So this is the general form. Okay, now we want to change this division of complex number into a general form. Okay, so we have 1 plus 2i over 3 plus I. And what is the complex conjugate of this division of complex number? Okay, so the complex conjugate is 3 minus I. So therefore, we need to multiply the denominator and numerator with the 3 minus I. Okay, so we multiply the numerator and denominator with 3 minus I. Then we will have 3 minus I plus 6I plus, minus 2I minus 2I square over 9 minus 3I plus 3I minus I square. Okay, so we have I square over here. So we can replace I square with negative 1. So after replacing the I square with the negative 1, then we have 3 minus I plus 6I plus 2 over 10. So therefore, we can simplify again this solution. And finally, we have 1 over 2 plus 1 over 2i. So this is the general form of complex number. So now we need to form a polar form of complex number. So first of all, we need to find value of r, then followed by the theta. Okay, so the question is to express the complex conjugate. Okay, so this is the complex number, original complex number, and this is the complex general form of complex number. So from this, we need to find what is the complex conjugate of 1 over 2 plus 1 over 2i. So the complex conjugate is 1 over 2 minus 1 over 2i. Okay, so from this complex conjugate, we can determine the value of r and theta. Okay, so for r, we can take a, which is 1 over 2, 1 over 2 square, and b is negative 1 over 2 square. So therefore, the r value is 1 over square root of 2, or you can write your final answer with the decimal form, which is 0.707. Okay, now for theta, bear in mind we need to find where is the location of this complex conjugate, in the Argand diagram. So from this Argand diagram, we can plot 1 over 2 and negative 1 over 2. So therefore, location is location at the fourth quadrant. So now this is the theta, but this is theta reference. Okay. Our theta should be over here. But if you want to give the theta in a form of reference angle, it's okay. I still accept it. Okay, now how to get the theta value? So theta value you can find from arctangent negative 1 over 2 over 1 over 2. Then we have negative 45 degree. Okay, so now negative 45 degree is located here. Okay, negative 45 degree. So negative, it shows that this is the reference angle. So if you want to get the original angle, then we need to subtract with the 360 minus 45. Then the theta is 315 degree. So the original theta is 315 degree. Okay, it's okay whether you want to find your final answer in the term of reference angle or the original theta. Okay, so therefore final answer is 1 over square root of 2 cos negative 45 degree plus I sine negative 45 degree, or 1 over square root of 2 cos 315 theta plus I sine 315 theta. Okay, that's all. So be careful when you get this question, something like this, right? So be careful because we need to express. Basically, we want to express this complex conjugate, not the original complex number. Okay.